Well, hello to all good people of the world. This is Paul Whittakin returning to you today with the Universal Law of Numbers, the 369 code. And what we're going to do is we're just going to do some 369 code arithmetic because it's something we need to do from time to time, because what we want to understand is that this is the 369 code. One way you can look at it. And these, in algebra, these are very, very important numbers. They're the ones that will occur in algebra because the 9 has a relationship with the 3. All the 9 numbers were 3 numbers. The 8 has a relationship with 4 and 2. All the 8 numbers are 4 numbers. All the 8 numbers are 2 numbers. All the 4 numbers are 2 numbers. So that's the special relationship. So we will address that. Then what I'm going to do is I'm going to refer us back to the concept of as above and so below. So we would consider maybe this the universal law of numbers below in that sense. And then we do arithmetic that's more conventional, and we would say that may be above. And what it's going to do is this will give us a family of numbers, and we can reduce them, and they will give us the 369 code. However, without reducing them, they give us the arithmetic that we're accustomed to, because 2, 2, 2, 2, 2 squared would be 4, 9, 3, 8, 1, 7, 2, 8, 4. Okay, so we all agree on that kind of arithmetic. Now, what I try and do is explain the entire system and condense it. So what I say here is 2 and 7 are the same number. On the left-hand side and on the left-hand side, they're the same number. On the right-hand side and on the right-hand side, they're the same number. And they will make a 9, as all of them will when we get to the 9th sequence, when we add the numbers together. So 2 and 7 are the same, 1 and 8 are the same, and 4 and 5 are the same. 3, 6, and 9, they're all the same too. They follow a little bit different protocol, but it's the same. Because they all make a 9. For instance, if I have one of these columns and then I don't have the other side, I would just flip over the column, and then I would make a 9, and it would give me the numbers that are on the other side. So basically 2 and 7, for instance, are the same number. 4 and 5 are the same number. And 4 is the same number on the right-hand side as on the left-hand side. And 5 is the same number on the right-hand side as on the left-hand side. And in fact, all numbers have components of the other numbers. So 9 has a component 1, 2, 3, 4, 5, 6, 7, 8, and 9. But also individually, each number 1, 2, 3, 4, 5, 6, 7, 8, and 9, they each have a 1, 2, 3, 4, 5, 6, 7, 8, 9 component as well. And this gives us the repeating sequence, for instance. But we will just do the arithmetic because we need to be familiar with these very important numbers, to memory, so to speak, and understand that that's a different set of numbers than the family of numbers that we arrive at with this set of numbers, doing that arithmetic. 4 squared, 44 squared, 444 squared, 444, 4 squared, etc. to infinity. It's a different set of numbers, but let's know them and do them and understand the concept, because the 2 numbers and 8 numbers, so all of these 8 numbers that come about are all going to be 2 numbers. So they're the same numbers, and how the scale works, because 1 times 1 times 1 times 1 times 1 all the way down to here is still only 1, but over here it's going to be close to 5 million. So there's a scale. 2 times 2 is 4, times 2 is 8, and we'll look at it like that. Times 2 is 16, 32, 64, 128. 3 times 3, 9, 27, 81, 243, 729, 2187. 4 times 4 is 16, 64, 256, 1024, 4096, 16, 384. 5 times 5 is 25, times 5 is 125, 625, 3125, 15625, and 78, 125. 6 times 6 is 36, times 6 is 216, 1296, 77, 76, 46, 656, and 279, 936. 49, 7 times 7 is 49, times 7 is 343, 2401, 16807, 117, 649, 8, 823543. 823543. 8 times 8 is 64, 512. 4096, 32, 768, 262, 144, and 2,097,152. 9 times 9 is 81, times 9 is 729, times 9 is 6561, times 9 is 59049, times 9 is 531441, times 9 is 4782969. So we want those numbers committed to memory, I suppose. Now, we don't have exams, and I'm not a teacher now. I don't mean to say that. But for purposes of understanding the 369 codes, they're very helpful to know, and you can do all of the algebra with them. Okay, so what I was talking about was condensing the numbers and demonstrating basically that each of the numbers have a component of each of all of the other numbers. So whatever. Okay. So what am I doing? I don't want to start with that one. I'll start better with, why not with this one? 1 and 8. 1 and 8 makes more sense somehow. 1 is the first number. I think, yeah. Okay, so basically what I'm doing is I'm keeping one column static in a sense, and then I'm rotating the other column by putting this is the left side of 1 and 8, the right side of 1 and 8, this is the left side of 1, left side of 8, let's say right side of 1 and 8. It's the same number. It's absolutely the same number. Okay, so this is the repeating sequence on 1 and 8 on the right-hand side. 209, 876, 543, 209, 876, 543. Forever. And so anyway, this would be the right-hand side of 1 and 8, and then if we just add it to the same sequence, which is 1, 2, 3, 4, 5, 6, 7, 9, 0, which is what it is up here, 1, 2, 3, 4, 5, 6, 7, 9, 0. We're just moving things a notch, just like we do when we do it with this. Okay, so if I'm doing it with this, moving a notch, it'll go from 417 to 369. And then it'll go to 258. And then it'll go back to 417. Then 369, then 258, then 147, 369, 258, 147. It's going 369, 369, 369. And that's what's going on essentially here as well, because we're just moving them one notch at a time. And when we do that, every single number will change. But it will change to what number? Well, it will change to the 369 code, meaning it'll go here, it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then it'll start at 1 again. It will repeat. That will go on to infinity. And that is the 369 code. 1 and 2 is 3, 4 and 5 is 9. 6 and 7 is not. 8 and 7 is 6. So anyway, 3, 6, 9. That's what it's doing. And in between as well. Now, with the 2 and the 7, we will get the same results in terms of we'll get all of the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. but it will give us the 369 code, because separated by the 2 will be 3, 6, and 9. And 4 and 8 will be 3, and 7 and 2 will be 9, and 5 and 1 will be 6, for instance. So what happens is these codes, these repeating codes on each side will generate the sequences, which is the 369 code. And the same thing applies to 4 and 5. Well, why? Because, once again, 4 and 5 on the left-hand side are the same number. Now, for 4, I might say 1975-30864, and for 5, I'd probably say 308-64-1975. But it's just the juxtaposition, which way the number aligns as it rotates around this static one. Of course, the numbers will be the same, but each time it goes 1, the whole thing goes 1, and every number changes, and it goes 7, 5, which is a 12 is a 3, then 1, 8 is a 9, then 4 and 2 is a 6. And it repeats, starts over at 7 again. It goes to infinity. So that's what these numbers are doing, and that's what I'm pointing out now. They're going to make it happen in other ways as well. So basically aligning these numbers and allowing one side to change and the other not. 049382716. That's the repeating front left-hand side of 2 and 7. 950617283. That's the repeating side of 2 and 7 on the right. And then we're just adding it to itself, but we're changing it as it goes along, another notch, but we'll get these same codes, 209876543, 209876543, or 123456790, 123456790. Those are the 1-8 numbers, the back and the front, like that. 1 plus 4 does that, 209876543, or 790-123-456, 790-123-456, 790-123-456. That's the 1 and the 8 number, the front and the back. And if I add them up like this, 1 plus 1, I can even take it all the way to the end, to the ending sequence. But we get the codes. Here's a code right here, 802-469-135, which is otherwise known as 469-135-8024. Or 1975-30864. I know that, that's from 4 and 5. It's the left-hand column. Or you could say 308-64-1975. Okay, gives us that. 2 plus 8 can give us this. In any case, point being that applying the arithmetic between the sequences is applying the arithmetic between the codes, and when you apply arithmetic to the codes, you always receive the same sequences, codes in return. And that is one way I choose to look at this entire operation. Now, all good people of the world, let me sign out here, but I do believe that we can all recognize this one thing. We are, the human race. Okay, this binds us together. It really does. It's something that we all have in common. And when we think of this, it sort of distracts us from all of the separations, because we fall into paradigms, Chinese people out there, Russian people out there, Americans out there, Europeans, whoever. Yet we are all the human race, and this unifies us in that sense. And I see a big picture, and I think we can all kind of agree about this. Whatever side you're on about anything, what we have is we have this Israel-centric American foreign policy, and then America imposes that on every other country in the world by any means necessary. Economic sanctions down to vilifying and demonizing and creating absolute boogeymen out of human beings, then committing mass genocide and horrific ways of murdering. Now, we don't all have to be stooges of these people, because 99.999999% of all of us in the rest of the world who are not white supremacists, all of the rest of the people in the world, do we really want to kill each other over the right to be, live under their subjugation? Not really, people. So please, not hate speech, consent to not consent to that anymore. Overwhelm them as the overwhelming majority. My name is Paul Wittekind. Peace and happiness to all good people of the world.